No.
Okay, guys, we are picking up where we left off Friday in lesson 1.5. Okay, lesson 1.5, we were just reviewing some basic inequality type stuff. And so that's where we're going to continue. All the inequality stuff you've learned during Algebra 1. So we already did the basics with graphing and whatnot, and just setting up some inequalities. We're going to jump into some solving at this point. So as we look at problem 2, the first example, what is the solution? So they give us negative 3 times 2x minus 5 plus 1 greater than or equal to 4. We need to solve it, and we also need to graph it. Thoughts on the first solving? Where do we start here? Miles? Distribute. You guys know it's not going to work with everyone saying they're quietly all period, right? Yeah, you know your teacher's not going to let that happen.
You let Maggie answer all the time.
Okay. We're going to distribute. So distributing, what do we have when we distribute? Go ahead, Sarah.
Negative 6x.
Okay. Negative 6x plus 15. We're still going to carry down the plus 1 greater than or equal to 4. So we distributed. What's next? On the left, we can what, Madison?
My mind just went blank as I was going to say it. Aren't you going to like... Oh my goodness.
What are the specific numbers what are you doing there?
Isn't it 15?
Yeah. Adding the 15 and 1? Because they are like terms, I think is what she's probably looking for. Okay. It's combined like terms, but still, just knowing you add 15 and 1, right? They're the constants on the same side. So 15 and 1 is going to make this 16. So now my inequality reads negative 6x plus 16 greater than or equal to 4. What's my next step? Okay, subtract 16. If it's negative 6x plus 16, we're going to subtract 16. If I subtract 16 on the left, subtract on the right. And negative 6x greater than or equal to, what's 4 minus 16? Negative 12. Bring this up here because I ran out of room. Now what? Negative 6x greater than or equal to negative 12? Final step is, AJ? Okay, divide by negative 6. Negative 6x divided by negative 6 leaves me with x. Negative 12 divided by negative 6 is what? 2. So x is what? I've heard x is greater than or equal to 2. I've heard x is less than or equal to 2. I don't know, there may even be a few out there just x is 2. Sign matters here. Sierra? We talked about this on Friday. It's one of our things I start up above. What did we divide both sides by? We divided by negative 6, yes? Anytime you multiply or divide both sides by a negative, the inequality sign reverses. When you have a negative number that's multiplied by the x or divided with the x, that's when you want to do it. I mean, the key is the fact that I divided both sides by negative 6. Because that number is negative, I'm reversing a sign. So it does become x less than or equal to 2. Okay? The place we talked about it, we didn't actually do anything with it. But on Friday, I kind of mentioned 2 rules right there. Dividing, multiplying by negative always flips the inequality sign. That's the step I'm talking about. And now, we also need to graph this. So, we reviewed graphing on Friday. Set up a graph. Put some numbers along with 2 there. I'm going to say 0, 1, 2, 3, 4. How do we graph? Sarah? What was it? Okay, closed circle, because it is equal to closed circle, so we're going to fill that circle in, and then it went left, less than, which is left. I probably mentioned this Friday, but don't make me guess which way you're shading. Okay? I'm not saying it has to get big and crazy, but make sure I can read it. That's old news, right? Remember how to do that? Do we want to do the next one or skip the next one? I was debating. Yeah, we can go ahead and do it real quick. Liz says skip it.
Skip.
You guys are okay with skipping it? Here's the deal. Am I done solving today? I'm not done solving. There's going to be more solving. So, okay, we'll skip it. And I don't really plan to only do one of these 2 word problems because there's some important stuff on the back of these notes. We've got to talk about our and or statements, compound inequalities. And I'm more concerned with you guys knowing what to do there. So, okay, let's go ahead and do problem 3. And we'll do the first example here. A movie rental company offers 2 subscription plans. You can pay $36 a month and rent as many movies as desired, or you can pay $15 a month and $1.50 per movie you rent. How many movies must you rent for the first plan to cost less than the second plan? Okay, guys. Now, keep in mind, I don't want just an answer. It's algebra. I want us to write an equation. Actually, an inequality for this. Okay, we've got to practice writing an inequality. And I would focus in on that last statement. The last statement asks the question, how many movies must you rent for the first plan to cost less than the second? So think about the key pieces. They're asking how many movies must you rent for the first plan to cost less than the second plan. That's what I have to think about. How many movies for the first plan to cost less than the second plan? So when I set this up, here's what my brain's thinking. I have to set something up where the first, whatever I use to represent the first plan, costs less than whatever I use to represent the second. So that's me trying to organize my thoughts. Thoughts on how to set up an inequality here? What do we know about the first plan? $36 a month, right? Are we talking about more than 1 month here? No, we're just trying to compare which one's the better deal based on what we do, right? So we really just need to compare 1 month. So that $36 a month is just 36. It is a flat 36. It's not changing unless we're doing multiple months, but that's not going to affect what I'm doing right here. Okay? So first plan, 36, less than the second plan. How can I express the second plan? Pay $15 a month and $1.50 per movie you rent. So what's my expression there? Miles?
15 plus 1.5
Okay. 15 plus 1.5, what variable did you say?
X.
X, okay. And it can be whatever variable. But it's 15, it's a flat 15 for the month, right? So that's a one-time charge for the month of 15. Plus, it's $1.50 per movie. Okay? Whether you pick X, M, A, Z, it doesn't matter. But it's 1.5 times X then. $15 flat out monthly charge, $1.50 per movie. Okay, can you solve this? Yes. We're actually going to answer the question. I want to know how many movies you must rent for the first plan to cost less than the second plan. So what's my first solving step here? To get X by itself, we should subtract the 15, move it over. So then 36 minus 15 is 21. So then I have 21 less than 1.5x. How do I get x by itself? Divide by 1.5. What is 21 divided by 1.5? 14. So I now have 14 less than x. Which, if I bring it out here and reverse it, that is what? X greater than 14? Okay, I always encourage that variable first. What does that mean for this answer? When it says, how many movies must you rent for the first plan to cost less than the second plan? Okay, more than 14. Can we rent just 14? No. Okay. So if you're going to watch more than 14 movies, then by all means, get the unlimited $36 subscription. But if you're not going to watch more than 14 movies a month, that's a lot of movies, but for some of you it's probably doable, I guess. If you're going to watch more than that, or less than that, I mean, then just stick with the $15 a month. So if we put this in words, it's more than 14 movies. Technically, we're not going to do half movies or partial movies, right? So technically, you could also say 15 or more movies, because 15 would be the first whole number movie you could rent. Okay, got some basics there. Flip to the back when you're ready. And if you remember last week, we talked about with equations, are they always, when are they always, sometimes, or never true? Yes? Well, we're going to do that with inequalities today. Inequalities can be always true, sometimes true, or never true. Just like last week. An inequality can be always true. If you end up getting a true statement like 5 greater than 3. Notice again, the variables dropped out. Is 5 greater than 3? 5 is greater than 3. It can be sometimes true. Sometimes true happens when you still have that variable. So if x is less than 3, that's when it's true. If x is greater than 3, it's not true then. Or never true. And never true is if you end up with a false statement. Now, I don't know if anyone's going to catch it, but that's not actually a false statement there. It's a typo if you think about it, because it says, if you end up with a false statement, like 3 greater than negative 1. However, 3 is greater than negative 1. So, if I tweak it a little bit, I'll make it negative 3. Negative 3 is not greater than negative 1. So that is an example of a false statement. So let's go through each of these real quick and look at how we can, know when to stop and how we can make our decisions. So example A. What is my first step to deciding if this inequality is always, sometimes, or never true? First step, as like almost everything we've done lately, Whitney? Distribute. So as I distribute, this is going to read what? Negative 6x minus 2 greater than negative 6x plus 7. I don't know about you guys, but I almost feel like I could stop now. Because when you take that next step, what's going to happen in that next step? Sierra? Yeah. If you have a negative 6x and you start adding 6x to both sides, because these x's are identical, they're going to cancel. So that's why I don't even really have to do that next step. Just look at what are my remaining pieces. And my remaining pieces are negative 2 greater than 7. Once those variables are gone, it's either always or never. Is negative 2 greater than 7? A negative is never greater than a positive, guys, in any way, shape, or form. If you can forget the numbers. Is a negative greater than a positive? No. Because this is the variable's canceled and this is a false statement, then this is an example of never true. B. First step again is distribute. Don't try and tell me you know the answer right now. Although some of you have done mental math and you do know the answer. However, show me a little bit. Okay, show me a little bit of work here. So if we distribute 10x minus 15, still minus 7x, less than or equal to, and still 3x plus 8. I'd like you to go one more step before you tell me you know the answer. What is that next step I can take? Okay, combine like terms. 10x goes with minus 7x, and 10x minus 7x is 3x. So 3x minus 15 less than or equal to 3x plus 8. I'm sold now if you're going to tell me, oh, I got it, I know it. Now it's not mental math either. What do you know? Okay, 3x's cancel out. You can subtract them if you want. Leaves you with negative 15 less than or equal to 8. So, what do you know? Is negative 15 less than or equal to 8? Yeah. A negative smaller than a positive? Definitely. So this is a true statement, which means it is always true. And I'm not saying you have to write true and false next to them before you write the always or never. That's just, kind of part of my teaching notes there. Okay, I know you guys, you can probably guess the answer for C, but let's see why it's that. Okay, step 1 is all we have to take in my opinion. So let's distribute. What's this going to look like distributed? (8x minus 12 less than 6x plus 6. If I claim I know the answer right now and I want to stop, are you okay with that? For the scenario of always, sometimes, or never. Yeah, what's the key here? (8x) and 6x. They're different. Are they going to cancel? No, I'm always going to have an x, which means this is going to be sometimes true. So yeah, if you can get it to that point, and we can see that your x's are different, I'm content with that. That tells me that you know what you're doing there. If you're thinking, I solved that, I really want to make sure that I'm right, what I have written down, x less than 9. So it's sometimes true when x is less than 9. Okay, we got that? Let's talk about the last section. And this is an important section. I feel like it's probably, it's not that it's that difficult, but, you know, the one that you may have forgotten the most about. And that is compound inequalities and or statements. You did these back in Algebra 1. Okay, so it's not brand new, but when we take two inequalities, they're called compound inequalities, they're stuck together using either the word and or. And inequalities, the vocabulary word for that is intersection. It's the intersection of two inequalities. And they say here where the two graphs would cross. So when we talk about being on a number line, I use the word overlap. It's where do the two shadings overlap. So I tend to say overlap instead of cross. That's for the and statements. Or statements or inequalities are referred to the union. And that's just you shade whatever you graph whatever you're told to graph. You don't worry about whether they overlap or not. It's just if you're told to graph it, you graph it. They put it there as all numbers included with the two graphs combined. Okay. So good news about these, as you look at a first example, you still know how to solve them. Okay, we'll talk about how to express the answer and how to graph the answer. Those will be the keys. So what is the solution of 7 less than 3x plus 1 and 3x less than or equal to 18? And then graph the solution. So first things first, we should probably solve. So how do you solve 7 greater than 3x plus 1? Get x by itself, we're going to subtract 1. So 6 less than 3x. And now to get x by itself, we're going to divide by 3, and I have 2 less than x. Because we're going to graph this, and I want you to be able to see it, I am going to go ahead and reverse this. When I reverse 2 less than x, it reads x greater than 2. And if you choose not to reverse it in this situation because it's an and statement, I could go with that as well. We'll talk about that in a moment. What is the key word that goes between these two? And. Don't forget that word. It does make a difference. I need it in there. And then the other half of this, 3x less than or equal to 18, means I'm going to divide by 3 and get the answer of x less than or equal to 6. Okay. This is one option for how to leave an answer. Okay. However, with an or statement, I'd say we're done. We're leaving it like this. With an and statement, do you remember writing a compound inequality together into one statement where the x is in the middle between two numbers? Because that's what I'm going to expect for an and statement. I don't know exactly how you're taught it, but okay, so and statement. My x is in the middle. It's between the two numbers. My general rule of thumb is always to put the larger number on the right end, smaller number on the left end. So if I'm doing that, 6 is on the right, 2 is on the left. Carry over your inequality signs. This is what? X less than or equal to 6, so what should be over here? X less than or equal to 6. Now this one, I flipped it for when we talk about graphing. This is X greater than 2, but this is 2 then X. So we need to flip it for the purposes of this compound inequality, so it's going to instead read 2 less than X. This would be how you express the compound inequality. These two inequality signs, when you've got this put together correctly, will always face the same direction. And if you put the larger number on the right, smaller number on the left, they will always be less than symbols. Okay? So this is what I will be looking for. I know if it was a Math Excel assignment, Math Excel would only accept that from what I recall in the past. Now let's graph it. I just chose to go 0, 2, 4, 6, 8. I don't know why. Earlier today I went 1, 2, 3, 4, 5, 6, 7. So do something. Get 2 and 6 on your graph. Now let's graph these individually and think about them. What does X less than or equal to 6 mean to you? We need what, Sierra? Okay. A closed circle on 6, it's equal to, so we're going to fill it in. And which way am I going? Okay, we're going to go left. Now, notice, I'm just going to put that in pencil right now. And in fact, I want to even put that up a little higher. That's a little closer than what I wanted. Okay, don't make this dark in your final graph or anything. I'm just putting this in pencil right now. So that's X less than or equal to 6. What's the other part of this? X is greater than 2. So there we need an open circle. Where's greater than 2 mean? To the right of 2. Notice, if we just shade where it shows shading, we're shading this entire number line. But this is an and statement. It's an intersection statement. Remember what it said up there? It said to shade or graph wherever the lines cross. I like the word overlap. Where do my lines overlap? They overlap between 2 and 6. So my shading is there where my pencil overlapped between 2 and 6. Do you need anything below 2 or above 6? No. And by expressing my compound inequality there, that is also indicating the same thing. Okay? This is when it says 2 less than X less than or equal to 6. This is saying X. My answer is between 2 and 6. Sound familiar? I will tell you, and statements are almost always, I can't say always, but almost always the shading's in the middle. Okay, that's the general rule of thumb with an and statement. There are exceptions. I don't even know if we'll get around to seeing them, but that's how it usually works. Are we okay with the and statement? Okay, let's try an or statement. What is the solution? And it says this or this. What's first? Yeah, we've got to solve and subtract 7. So if I subtract 7, 7 minus 7 cancels. I have K less than or equal to 6 minus 7 is negative 1. What's the word I have to write in the middle? Or. Don't forget to carry the word or down. 8 plus K. How do I solve 8 plus K? If it's positive 8, we're going to subtract 8. So then I have K less than 3 minus 8 is -5. Because it's an or statement, you're done right there. An or statement, this is the only way you can write it. It cannot be written as a compound inequality where the x is in the middle. It's only for and. So you're done right there. Let's graph this. Okay, I labeled -6 up to 0. Remember, you're in negative world. Are your numbers going backwards? Or not backwards, they just seem like it. Okay. What did I do wrong? Okay. I got a mistake up there. Did anyone catch it? The red flag to me is that both my signs are less thans. Did I say it right at least maybe at the time? Do you see it, Miles?
Yeah, the first sign needs to be flipped.
Yeah. Why did I flip my first sign? Please make sure you didn't do what I did. It may have just been me that did that. I don't know. All I know is when I was getting ready to graph, and both my graphs were going the same way, I was concerned. Okay. K greater than or equal to -1. What's that graph look like? Closed circle, fill in the circle at -1 because it's equal shaded to the right now that I have my sign going the correct way. K less than -5. Open circle, going to the left. Okay, it doesn't matter that they don't overlap. You just shade whatever it tells you to shade. So with the or statement, generally tends to go out. Questions on that one? Okay, I'd like to do the next one because it's an and statement, and then that would be a good stopping point for us. Or a finishing point, I should say. So what is the solution of 5 less than or equal to 3x minus 1 and 2x less than 12? Graph the solution. Like all the others, you are starting by solving. Lots of practice solving today, right? If it's 3x minus 1, let's add 1. So 6 less than or equal to 3x. What do I do now? Divide by 3. Less than or equal to x. If you can get your graph correct, you can leave it like that. But I always encourage for graphing purposes to flip it. And so then it's x greater than or equal to 2. What's the word I carry down? And. (2x less than 12), I need to divide by 2, and x is less than 6. Okay, this is one way to write your answer. However, for final answer, put it together, write it as that compound inequality, where x is in the middle. What is x between? 6 on the right and 2 on the left. It's x less than 6, so put the less than sign there. This is x greater than or equal to 2, but if I reverse it, 2 less than or equal to x less than 6. If this is my answer, where's my shading going to be when I graph this? Yeah, between 2 and 6. X is between 2 and 6, so I'm graphing between 2 and 6. 0, 1, 2, 3, 4, 5, 6, 7. What can I circle on 2? Closed circle. Going to the right, because it's greater than or equal to. What can I circle on 6? Open circle. Less than 6, so going to the left. Or notice, my shading is between. Typical and statement, my shading goes between. Typical or statement, my shading goes out. What about the next 2 problems I'm going to skip over? They are what type of statements? Or. What's their graph going to look like? They go out, right? Since they are or statements, their graphs would be going out from each other. Okay. Your homework. Practice 1-5 workbook page 1 through 14 and 19 through 24. Okay. Come back with that. Ready to go tomorrow. And then we just have lesson 1-6 notes. I'm hoping we can get done with those tomorrow, and that put us on track for a chapter test Friday. So we'll see what happens. Nope.
You were there.
Okay. Any questions? Liz, did you get everything you needed?
I played the whole game.
Okay. Well, I think we're done. So have a good day.
Why your sister should on the track.
Okay, sounds good. Bye. No, I was not at the game.
We won.
I saw. Trust me, my son wants to know. So I was checking Twitter for scores.
We scored 12 in the first 5 minutes and couldn't score the rest of the game.
I'm not sure that sounds like a good thing. But
Yeah, I'm like, what are you?
That's not a good thing.
no.
It's okay, they made adjustments. But it's 94 degrees outside.
It's freezing in this classroom. I forgot the room in the school is super hot.
Today?
Yeah.
Why are-
Especially down by Huntley's because they have all the windows open.
Well, someone said something about this morning. The air wasn't working in the middle school.
Oh, yeah.
Like it was really warm or something. I don't know.
Yeah, Huntley's was really hot today.
So-
Yeah, I get 36.
I'm just used to drive.
I fill my gas tank every day. What? And I get free gas. My dad owns a business, so he just writes off gas. And the gas nozzle at my house doesn't like stop when it hits it, so found that out the hard way.
I stopped early because I wanted to make sure I beat the announcements, but
Yeah. She forgot to close the gas thing. And we started driving, and this guy on a motorcycle like pointed out, and I was like, what is he pointing at? And then in the middle of the road,